Welcome to today's video on voice test views. The RTP stream test creates a direct connection between the VoIP caller and receiver, sending voice packets to measure aspects like mean opinion score, MOS, packet loss, discards, latency, and packet delay variation, or PDV. It also allows you to configure DSCP and codec values. Some typical use cases for this test are identifying the node responsible for a degraded RTP stream, analyzing effects of BGP route changes on the RTP stream, and measuring call audio quality. Let's get into the view page. The views page is broken into 3 panels. The top panel contains the test selector and global filters. The primary panel contains the views list, metric selector, and timeline. The secondary panel contains the detailed metrics tabs, path visualization, and BGP route visualization. In the top panel, you can see the drop-down menu for the name of the test and source agents. When you get to this page, no specific selection is made, so the metric value you see on this page will be an aggregated value of all the tests. If you want to see specific data, just use the drop-down menu to select the agent. Next are the Save and Share buttons on the top panel's right side. You can save and keep the event indefinitely for recording purposes. Once the test is saved, the event will be listed in the saved events under the sharing menu. This can be shared with others. The sharing menu enables users to easily share test data, whether with fellow platform users or individuals who do not have a platform account. This feature allows you to troubleshoot and analyze test results alongside colleagues, partners, or providers, irrespective of their subscription status on the ThousandEyes platform. This sharing function generates a share link, a URL leading to a read-only ThousandEyes test results web page. This page can be accessed by anyone possessing the share link, and you retain the option to deactivate or revoke the link at any time. The primary panel reveals view layers, the metric selector, and the timeline. In the secondary panel, you'll find comprehensive metrics along with several tabs. The Map tab illustrates the global locations of the test's vantage points. The Table tab offers detailed information about the test from each agent. The first thing we need to focus on is the views layer. The RTP test provides multiple layers of tests along with the RTP test. The RTP test provides VoIP-related metrics such as MOS, loss, discards, latency, and PDV. The MOS, or mean opinion score, is an indicator of voice call quality, which is the most important metric in an RTP test. It ranges from 1 to 5. An MOS of 5 indicates excellent voice call quality, while an MOS of 1 indicates poor quality. This test has an average MOS score of 4.3. We can confidently conclude that the voice quality between the source and target agent is excellent. You can see later on in this time view, the MOS went down to 1.29, which indicates a drop in call quality. From here, we're able to investigate further why the MOS is so low. In the Map tab in the secondary panel, you can see the current codec setup of the test and the other available metrics like loss and discards. You can also find the same details in the tabular format under the Table tab. In the secondary panel, we immediately see that some high metric values cause the low MOS. You can see discards, latency, and PDV all going up. As the voice traffic is latency sensitive by its nature, high latency can cause a huge negative impact on the voice quality. Due to the nature of voice traffic, setting and checking the DSCP tag is essential. DSCP tags mark the priority level of the packets for network transmission and classify their class type, aiding in congestion management and determining which packets to prioritize by dropping last when a queue becomes overloaded. Under the table, you'll see what DSCP tags were received from the test. When you set up an alert, you can set it up with DSCP so you get an alert if there is an unexpected tag received. In the network layer, the RTP test provides path visualization. Path visualization lets you visually map the path trace data between the source agent and the target. This helps pinpoint potential problem areas within both private and public network infrastructures. As you can see the hop-by-hop details, you can see exactly how the traffic is routed and get the details immediately if network issues arise. BGP route visualization visually represents how data traverses the internet, assisting in troubleshooting issues preventing packets from reaching their desired destination. The RTP stream test assesses the quality of RTP voice and video streams between ThousandEyes agents acting as voice over IP user agents. This test provides industry-standard MOS values to validate voice quality and more. It also offers the ability to check DSCP tags, which can reduce the time spent addressing degraded voice call quality. By leveraging the RTP test and integrating insights from these view layers, you can comprehensively understand your organization's voice quality. SIP server monitoring is crucial to ensure optimal call quality and avoid service disruptions. If a SIP server is unavailable, it can lead to communication breakdowns and potential harm to business reputation. ThousandEyes adds value by providing real-time performance insights, enabling early problem detection, and ensuring consistent, high-quality VoIP services. Our SIP server test provides 3 key metrics: availability, response time, and total time. First is availability. This is the percentage of time that the SIP server provides a successful response. Availability tests the basic connectivity to and the response from the target SIP server. If the SIP response is either 200 or 300, or the code specified in the desired status code setting, this is considered a successful response and the availability metric is marked 100%. But if not, it's marked as unavailable for that test measurement. The average availability can range anywhere between 0% and 100%. The Map tab shows a breakdown by error type, such as DNS, Connect, Register, and Options, and any active alerts. When a specific location is selected, the Map tab reveals the SIP response code, a clickable link for Register and Options request headers, a color-coded square icon, and any active alerts. The timeline then lays out a graph of average availability. If you select an agent, the agent's availability data is plotted alongside the average availability. Moving over to the Table tab, this provides data for each of the agents assigned to a test. This includes agent name, date and time of data capture, target IP address, SIP response code, number of redirects, and error type, along with error details, if any. The second metric is response time, also known as time to first byte. This measures the time elapsed from the request initiation until the first byte of the server's response is received. The Table tab shows timing information for each agent, including response time and its components, DNS time, connect time for TCP, and wait time. Finally, we have total time. This represents the time taken to complete all the phases of the test. It provides a detailed breakdown of the timings per agent and overall averages. On the Table tab, you can see the agent name, date and time of data capture, total time, and the component timings, which include DNS time, connect time, redirect time, register time, and options time. And that wraps up today's video. Thanks for watching.